Suppose we draw two dots on a piece of paper. The shortest distance between them in the plane is a straight line. But if you bend this paper in half, the 2 points can then overlap and be infinitely close. It's the basic principle of physics that wormholes travel through space and time. A wormhole is a theoretically existing celestial body derived from the theory of general relativity. It's a time tunnel connecting two distant regions of the universe. General relativity and quantum mechanics are two pillars of modern physics. They rule the physical laws of the macro and micro worlds respectively. These two theories perfectly describe almost all observed phenomena in nature. But for more than 100 years, the world's greatest scientists have never been able to merge them into one, thus forming a grand unified theory of everything. And research on wormholes has been crucial in developing the theory of everything. In 1935, Einstein and Nathan Rosen were working on a unified quantum theory of gravity, published a paper called ER, and developed a concept called the Einstein-Rosen bridge. In general relativity, the universe is a four-dimensional space-time consisting of 3 dimensions of space and 1 dimension of time. And gravity affects space-time itself to some extent and bends it, i.e., all objects with mass distort the space-time around them. The greater the mass, the greater the object, the greater the curvature of twisted space-time. If we consider our universe as a 2-dimensional plane, the curvature caused by gravity creates a funnel-like shape. And when the same spatial bending occurs at another location, then there's a chance that the very tops of their bends could be connected. This is the equivalent of creating a fast track between 2 points in the universe. This tunnel is also known as a wormhole. Why wormholes are the most fascinating space-time tunnels in physics. In 1915, shortly after the publication of the general theory of relativity, Carl Schweitzer, a physicist serving in Germany, was on the battlefields of smoke-filled Russia. The exact knot of Einstein's field equations was calculated. He found that if the entire mass of a given object is compressed into a small gravitational radius, all matter and energy, even light, will be imprisoned. From the outside world, this celestial body is a being of absolute darkness. It's a black hole. The boundaries of a black hole are called the horizons. So a black hole is a celestial body that warps the space-time around it to the point where light can't escape from its event horizon. If we use the embedding in math to represent its geometry in the universe, then the space around the black hole will take the shape of a funnel. The closer the structure of space-time moves from a flat state to the black hole horizon, the closer the region of, the stronger the influence of concealment. The curvature of space-time will also gradually increase, and the circular area formed by the line of sight of the black hole seems to be like a hole in the fabric of the universe. So what does this strange hole mean? What happens if a ship approaches its edge? Since in this 2-dimensional geometry, we're ignoring a spatial dimension and a temporal dimension. So the line of sight of a black hole is actually a sphere, instead of a circle, as depicted in the movie Star Trek. The gravity of a wormhole distorts the light around it, produce a gravitational lens effect. And wormholes don't have a field of view like black holes, so we can even see images of objects on the other side of the wormhole. Through this wormhole, you can instantly travel to another dimension far, far away. In theory, the distance connecting two spaces can be infinite. If we express the black hole in terms of the mathematical equations of space-time geometry, and in doing so, replicate a reverse black hole after, and you'll find that it forms a special object with properties completely opposite to those of a black hole. Put it simply, it doesn't absorb matter and energy like a black hole. Instead, it's a continuous release of matter and energy outward. This is a hypothetical celestial white hole predicted by the theory of general relativity. When we connect it below the black hole and extend it based on the symmetry of equations and math, a wormhole with a tubular structure was formed. It's actually a link between a black hole and a white hole. Matter swallowed by a black hole is transported through a wormhole to a white hole, and it's being radiated. But a wormhole can also connect a black hole to another black hole. If that's the case, the wormhole becomes a temporal prison. It'll never come out. If structures like wormholes do exist in the universe, it not only connects two different time periods together, it can even be a gateway between separate parallel universes. But this type of wormhole has a serious drawback. It's just that it can't be stabilized. Even if an elementary particle with a small mass passes through, the wormhole passage is all close in a fraction of a second. If a human ship wanted to travel through the past, it's likely to crash into the dense singularity at the center of the black hole, so it's virtually impossible to travel safely through such a wormhole. But there are other models of wormholes with different geometries that exist mathematically and have better physical properties. For example, when a black hole has an electrical charge as it rotates, the starting point of its center will no longer be a fixed point. Instead, it's a circular ring. This will allow the substance to pass through, and thus, time travel. But such a wormhole can only cross from a black hole to a white hole in one direction, but you can't go back the way you came. In this regard, theoretical physicists, following the general theory of relativity, a more complex and feasible mathematical structure was conceived, even beyond the wormhole model of black holes and white holes, allows for truly free time travel. For example, unlike Einstein's Rosenko's Maurice-Thorne wormhole, not only does it have no event horizon and no singularity, and very stable in time, no closure occurs when an object passes through. This structure in a purely geometrical sense does not generate a strong gravitational force, so the ship can stay in its neighborhood without being pulled in by its gravity when we're going to try to cross it. The spacecraft may be moving along a lateral geodesic formed by the curvature of space-time, circling around the wormhole and then coming out the same end where you entered it. That's why I want to go back in time. It's necessary to orient the ship precisely towards the center of the wormhole. This elegant Maurice-Thorne wormhole, it seems to fulfill all the necessary conditions for the possibility of interstellar travel, but it has to be stabilized with an exotic substance to maintain its structure. This strange substance is negative energy. Negative energy is a form of energy that acts in opposition to ordinary energy. Scientists have discovered the negative curvature created by negative energy resists the tension of space-time, so that it doesn't collapse inward and close. However, negative energy is currently only a microscopic quantum effect in the universe. It has no way to exist in the macro universe. So stable wormholes can't exist in reality. But such a clear conclusion is only based on the general theory of relativity. But we all know very well, general relativity is not a perfect theory. It does not incorporate quantum effects on the microscopic scale. For example, according to the quantum mechanical description, there is a quantum rise and fall in what we call the vacuum of the universe. There will be random particles in space. It contains both positive and negative particles. And a vacuum is actually a state formed by positive and negative particles canceling each other out. And in the process of quantum rise and fall, it creates a negative energy to maintain the conservation of energy in the universe. In the experiment, it causes two metal plates in a vacuum to move inward and merge together. The Casimir effect. There is a recent view that there are actually tons of wormholes on a microscopic scale. Quantum entanglement, for example, is probably a phenomenon due to wormholes. The nature of the instantaneous movement of microscopic particles and the principle of inaccuracy is actually traveling through a wormhole. Although at the macroscopic scale we haven't found wormholes yet, but there's a good chance we're living in a sea of wormholes, since only particles as small as microscopic particles can travel through it. That's why it doesn't affect our lives in any way.